I think we had a regular class, online class. We didn't have a regular class last time, so I'd like to spend a little bit time to review the chapter 7 regarding to the ER modeling. As I informed you before, you should keep this handout, chapter 7 and 8 handout that I gave you a couple of weeks ago. So, to model the using the requirement and the request, for example, in the central database, company database, our goal is to build the company database based on the given the requirement. Sometimes the information are not that fancy. So your customer may provide a bunch of files or just a report or the printout or the regulation. From those information, you need to find which information should be managed in your database. That is modeling. Okay. So, for example, in our sample database, company database, for example, first black is for the department. The company is organized into department. Each department, blah 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 blah. So, first step is to identify such an important information or real things, past things. That is called what? Entities. You need to find the entity. What can be the candidate of entity in this example? Department, project, employee, and dependent. Right? For each the entity, we need to find what? Attribute that describe each entity. For example, for the department, we can find the name, number, manager, and starting date of the manager, and several locations can be attribute of the department. Similarly, we can find the attribute for a project like the unique name, unique number, and single location. After you identify the attribute, you can decide the key attribute. What is a key attribute? Using that key attribute, you can identify specific entity data. Okay, for example, department name. Using department name, you can get all the data for that department, like the HR. What about the employee? What can be the key attribute of employee? Social security number is a unique number for each employee. Also, is there only one the key attribute for each? Sometimes it can be multiple, like the employee ID can be key attribute. Also, what about dependent? Can you find that the key attribute of the dependent? No. So that is called what? Weak entity. It can be considered as an entity, but it doesn't have key attribute. So we need to identify the other entity who can help to decide the key attribute. That is called identifying relationship. Through the identifying relationship, you can get the key attribute of it. For example, social security number of employee. So key attribute of the dependent will be social security number of employee with the name in dependent. So that is the entity and weak entity and attribute. After you identify the attribute and the entity, the next step is relationship. So you can find the relationship between the entities. Sometimes two entities, sometimes three entities, sometimes one entity. Like the employee, supervision. Employee supervise employee. So one employee can be used for supervisor, another one is used for supervising. Okay, it's called a recursive relationship. In case there are two entities for the relationship, it's called the binary relationship. Regarding to that binary relationship, you need to decide the two constraints, two conditions. One is participation, full or partial. In other words, mandatory or optional. For example, the manager relationship between employee and department. It's a partial or full. In other words, Are all employees manager? No, only partial part of employees. Some of the employees are manager, the others are not, which means it's a partial optional participation. So, however, what about the works for between employee and department? Each and every employee should have department. Also vice versa, department should have at least one employee. Otherwise, if there is no existing employee, department is nothing. So it's a full participation. So you need to decide full or partial. For the full participation, you can use double line. For the partial or optional participation, you can use the single line. Another constraint is what? It's a
The school is closed.
yeah, I know that. But some of the students wait for the class, so I'm going
There's
to
no more classes.
yeah, I know. I heard that just before, so I'm going to.
So how long are you
as
gonna
soon
be
as
here?
possible.
How long are you gonna be here? Because I can't really let you stay.
I don't know exactly. You guys informed very, very lately, so I didn't have enough time to inform to the student.
So give them assignments
Okay.
and get out of the building because I can't let you guys stay in the building. Okay?
Let me have 30 minutes.
All right. My supervisor comes here. It's up to you.
Okay. What do you want? You wanna start here, or if you guys want, so I can continue. I think the outside is. But it's okay. Go outside. No, don't worry. They are treating me. Okay. Because they informed too late, just 30 minutes ago. Okay. I try to finish as soon as possible. So if I have a time, I try to prepare only the online the lecture, but 30 minutes is not enough for me. Okay. Then what else? The cardinal integration. So, for example, the manager. How many departments can you manage as a manager? One department, right? How many managers for each department? One manager. It's a one-to-one mapping. Think about the set theory that you learned in elementary school or the middle school. So one-to-one mapping. What about the department and employees? How many employees? For each department? Many. And how many departments for each employee can work? One. So many to one. Or it's called one to many. Many employees work for one department. So that is one to many relationship. The last one is many to many relationship. What is the example in our company database? Employees and projects. One employee can work for many projects. And one project can have many employees. So it's called many to many relationship. So you need to decide such a constraint. Two constraints. One is the ratio, cardinal integration. Another one is full or partial participation. Sometimes relationship can have the attribute, like the number of hours. But that's only for many to many relationship. Okay? Those are the whole thing that we learned in the last class using the recorded video. So you need to study more to understand what we have learned in the recorded video. Then sometimes those information are not enough to represent the customer request or the requirement. For example, this is another handout. Oops, that's for me. So why don't you take a, it's a quiz 2 and 3. So we are not going to solve that problem in this classroom. Instead, it's going to be your homework at the class. But we are going to use the quiz 2 and 3 to explain about the chapter 8. So why don't you go to the quiz 3. This is the requirement or request for Sacramento County News. agency. It's a small news agency. They try to build a database for their data. So first the requirement is a picture. Picture has a number, picture number, a date, height, and width. So we can easily identify what? Entity first. Picture entity. Then what can be the attribute? Picture number, the taken date, height, and width. Right? So those are the attributes for the picture. I think we can use the a number as a key attribute. Right? Then what about the next requirement? For a picture, we distinguish between pictures that have been taken by a photographer working for Sacramento News and pictures that were bought by Sacramento News from our agency. Can you understand what they are saying? There are two types of pictures. One is internal picture. Another one is external picture bought by the other agencies. However, both of them are pictures. Yes, come in. Both of them are pictures. So, can you identify any entities? Photographer. Later. Agency. If they are mentioned details later, we can use them as entities. Otherwise, which means important. If they are not very important data, we can use them as the attribute. However, what about internal picture? And what about the external picture? How can you represent such a characteristic?
It's an attribute.
Attribute.
Multi-value.
Multi-value. So let's So this is a picture. So we can find the picture number and name and so on. Height and width. Then type. Let's say type. Internal picture, external picture. It's not multi-value, it's okay. However, we distinguish between the picture that we taken by a photographer. So we need to keep photographer for internal picture. This attribute of attribute. How can you represent? We didn't draw. There's no way to represent attribute of attribute. Delight. In case if that is internal, it has what is that? Photographer. If that is external, it has agency. No, we cannot represent such a complicated requirement request. Also, one more thing is, anyway, these types are what? It's a picture. It's also a picture. It doesn't make sense. This is the picture, but it's an attribute of picture, right? So, instead, using attribute to represent internal and external, we are going to create the entity, right? Internal entity, internal picture, external picture. So it has the photographer and agency. However, this is a picture, this is a picture, this is a picture. So we cannot use the traditional relationship that we learned in the chapter 7. Instead, let's take a look at this is the picture that this is a kind of classification of a picture. So we are going to say this is the super class and these are the subclasses, and all of these are actually one entity. For what? Picture. This is a picture entity 1. If that is the internal picture, it has number, it has the width, it has a height, it has the name. Right? Even though that is the internal. If that is the external, it has all the information. So this is the one entity for picture. Then it can be classified into internal and external. This is called super and subclasses. Why don't you go back to your young child or the baby when you are learning something from your mom? Like when I was very young, my mom said to me, this is an apple. Also, this is an apple. Apple is rounding or like this. Then this is another apple. And finally, I learned this is the apple. Apple is usually rounding and sweeting and so on. Then, when I see a new apple, even though my mom never told me this is the apple, but I can recognize this is an apple, right? That is the thinking process, the training process. How can you learn something from the example, right? From the sample, like this is an apple, this is an apple, this is an apple, this is an apple. Then you can define. You can have your definition. Sometimes it can be linguistic definition. Sometimes it can be just imagine. But you know what is the definition of the apple. Then, when you see a new apple, you never saw this is a new apple, but it is not difficult to decide that this is an apple. Even 3 years old, 4 years old, kids can do that. At this time, this is called what? Generalization. And this is the red apple. This is the blue apple. This is the Fuji apple. There are 3 different types of apple, right? This is called what? Specialization. So human being can learn something, can be trained through 2 main thinking process. One is generalization. Another one is specialization. So generalization and specialization are very important, not only for the computer science or data modeling, but many other cognitive research use such a thinking process. Philosophy, or even the medical, they are using such a 2 main thinking process: generalization and specialization. What about this one? Picture, internal picture, external picture. First, we identify the picture, then classify into 2 groups. What is that? Specialization. This is a specialization. Then, vice versa. We identify that this is the internal picture, and this is the external picture. Then, finally, we recognize they have a common thing. That is a picture. What is that? It's a generalization. So, specialization and generalization. Unfortunately, ER modeling cannot take care of such a specialization or generalization. Both of them consist of superclass and subclasses. Superclass looks like parrot, and subclasses looks like children. Looks like parents and children related, but they are actually same entity. It's a picture, but it can be classified or generalized. So to address that part in ER, it's easy to learn. As we spend just a couple of hours to learn it. Then everybody can do that. It's not very difficult, right? That's the benefit. However, it cannot cover the all realistic information and database. Sometimes it's hard to represent very complicated relationship like this one. There's no way. So we write extend the ER into ER. The E, the first E stands for extended or enhanced ER model. What can be extended? Specialization and generalization. So we can represent most of the thinking process or the characteristic of your information can be represented by using super and subclasses. However, in modeling, actually specialization, generalization are not different. Because we need this modeled data, right? Picture has two, internal and external. So generalization and specialization represent the thinking process. We don't need such a thinking process. Instead, we need super and subclasses. That is different from the relationship. Okay? Relationship is the entity. However, in here, this is just a superclass and subclass. On the other hand, did you take any course in object-oriented modeling? CS 400 or 390. So did you learn the Java or the C++? Those are object-oriented program, which is based on object-oriented concept, like the object, inheritance, probably you learned the encapsulation, you learned such a thing. If we can use such an object-oriented concept in our modeling, we don't have to worry about this. So we can simply define one object. Then object has a method, and the object has the inheritance. So the attribute in picture can be inherited to the subclass. It's so simple. However, ER modeling is not based on the object-oriented concept. So to represent such a model, such a characteristic of your database, we need to extend the ER modeling. Somebody may be curious, why don't we use object-oriented modeling for data modeling? Yeah, that's a good idea. So many researchers actually try to build the object-oriented database model. Yes, even there are commercial DBMS, object-oriented DBMS systems, but they are not very popular. Instead, relational database model is more popular than object-oriented database model. Okay? The reason is not because object-oriented model is not better than the relational model. No. Object-oriented model is more flexible and powerful. But because what? The DBMS market is full of what?
Relational database.
Relational database owned by the big company. Oracle, the IBM, others. Those are the Microsoft. They are the major vendor. They don't want to be risky to change relational model to the object-oriented model. That caused the actual problem for what? Database programming. Programming part is purely object-oriented, like the C#, .NET, C++, Java. All of them are object-oriented modeling, programming. But our database modeling is not object-oriented modeling. There is a gap. So that is the reason it's not easy. So we will see such a difference in advanced database, not in the database design. We are going to focus on relational database only in this semester. That is the motivation of the extended, enhanced ER modeling. Why don't you? So let's take a look at this example. So we define the employee. Let's make the employee details. So suppose that we have the employee maybe further group into secretary, engineer, and technician. It's kind of types of job. Okay. Also, we can classify the employee as manager or non-manager. Also, we can group the employee, salaried employee, or hourly based. In other words, full-time employee, part-time employees, like that. Can we represent such details of the employee using ER modeling? Not easy. You can do a little bit, but not close to what I want here. Because all of them are entities. One entity, employee entity, right? It's not, the only way is attribute, but attribute is not very powerful. So we need to address that problem using super and subclasses. Like this. Okay? So, employee. Let me use. What did they say? Okay, good. So we have employee. Clear. So we have an employee over here. So this is what we did in the chapter 7, but as we saw in the previous slide, so it has a secretary and technician and engineer as a types of job. Okay, how can we represent such a thing? Using specialization. We can specialize employee into secretary, technician, and engineer by what? Job time. Okay, so we can create super and subclass. This is one group. Not only one group, there are many super and subclasses, like the employee and manager. Also employee and hourly employee or salaried employee. There are three. In this example, there are three super and subclasses over here. Another benefit of using the super and subclasses is, for example, we need to keep track of typing speed of the secretary. This is the attribute of the subclass. The other technician or engineer, they don't need typing speed. So if we create the attribute of employee for typing speed, many of them actually don't need the such attribute. It's not common thing. So we can create the attribute for each subclass only. So we can, for example, here we can create the typing speed, or we can create the, I think T grade means technician grade, specialty, special or whatever, beginner, or engineer time. So we can create. Also another thing is secretary, technician, engineer. All of them are employed, which means they need name, social security number, birthday, and address. We don't have to create the attribute separately. We can generalize into one. So all description attribute in superclass can be inherited to subclasses. It's much more convenient. Actually, that is object-oriented concept. So we can adapt such an object-oriented concept to extend ER modeling. What about this one? Employee and manager. It's a superclass and subclass. How many subclass? Actually one. So in this case, it's also super and subclass. Somebody may add non-manager employee, but we don't need non-manager employee. So that is the reason it has only one subclasses, the manager. When you are using the super and subclasses relationship, you need to think about two constraints, two conditions. First one is So for example, employees. We have employee and we have three subclasses. Secretary, the technician, engineer. So it has their own attribute and common attribute. If you do not allow the other types of job for employee, in other words, only you have the three types. So all employees should be one of job. That means should be full participation, just like the full participant in relationship. So all the employees should be at least one of subclasses. That is called full participation. Or if you allow the employee other job who does not belong to one of these, but I don't want to create the subclass. At that time is partial, optional participation. Okay, like the new employee. New employee for training period, there is no specific job. It's a training or intern. So at that time, if you allow such an employee who does not belong to any of this, it's called partial participation. Full or partial. As you can guess, double line means full, single line means partial. Another constraint is I'm the employee, so Lee in secretary as well as technician. Lee is in secretary and technician. James in secretary, technician, and engineer. So it can be more than one, two, or three subclasses. It's an overlap. That is called overlap. Or I don't allow such overlap subclasses. Only one of them. That means it's a disjoint. So you need to identify the two constraints. One is full or partial. Another one is overlap or disjoint. So how to represent overlap and disjoint? Just a circle. So this is the way to draw the ER diagram for generalization was under superclass and subclasses. Full or partial from superclass. Then circle. In case disjoint, D. Otherwise, overlap, O. Circle, O. Represent. So there are four types. One is full, partial, full, partial, no full partial, full overlap, full disjoint, partial overlap, partial disjoint. So you can identify such a constraint from super and subclasses. Okay, let's look at this example again. Yes. This is the example of the employee and secretary, technician, engineer. Let me ask you, is it the full participation or partial participation?
Partial.
Partial, which means there are employees who does not belong to any of the subclasses. Okay, others or the non-job type. Okay, what about Does it allow overlap the job? No, because it's a D. D indicate disjoint. Disjoint means only one job is possible. So it's much more powerful than ER modeling, right? It can represent very complicated condition using ER modeling. Okay. It's very slow. Yes.
What does it mean, disjoint?
Disjoint?
Exactly.
Disjoint means it's separated. So it allows only one type of job, the sub-classes. Disjoint means it's separate. There is no common thing. Okay, this is the final, the improve. Here, forget about the project and trade union. For this, how many entities do you have? Just one. It's for employee. Okay? Then employee. How many groups for super and subclasses for employee? Three. One is employee and secretary, technician, and engineer. This. The second, employee and manager. Third, employee and salaried employee, hourly based employee. Then, what about the employee and manager? Is it full participation or optional participation? It's optional, which means some of employees are manager, the others are not. Actually, there is no disjoint overlap because it has only one. Okay. What about this? It's a full participation, which means employee should be either of hourly or salary. Also, does it allow the overlap, which means both salary and hourly? No. It should be one of this. It's a disjoint. Okay? That is the way of understanding ER diagram. Another benefit of the using the ER modeling is you can use subclass to create what? Relationship. Actually, employee and project manage. Some of the employees actually not manager. So it's a waste of the notation. However, if you create a relationship between manager and project, yes, it's a perfectly matching, right? Then somebody realize, let's go back. Oops.
So, is there any symbol for the overlap?
Overlap is a circle O.
Circle.
Yes. Okay, here. There is only one thing that I do not explain it. What is it? Can you find any? I explained everything except just one.
Belongs to trading and yes.
You know this. You already covered in the chapter 7. What about this? That indicate whether this is the specialization or generalization. It indicates the generalization, which means first, your customer gave the whole information about salaried employee. This is the information about the salary. This is the information about hourly based employee. Then, as a designer, modeler, you realize salaried employee, hourly employee, all of them are employed. So why don't we generalize into employee? So this is a generalization. Similarly, secretary, technician, engineer. So your customer provide, I need to keep track of secretary, I need to keep track of technician, I need to manage the engineer information. Then, after you analyze the data, all of them are actually employed. So you can generalize into employed. So that is the generalization. To show that either generalization or specialization, we can use, it's called a cup. What about the specialization? It's hat, this way. However,
So
that,
this is generalization.
this is a generalization. It's not this way.
The opposite.
Opposite is the specialization. That's only for the symbol. In modeling, that's not important. Okay? Why? We don't need such a specialization or generalization in our database. What we need is model, super and subclasses. So this is not very important. You can just ignore that. However, I have one question. For generalization, I build a employee from secretary, technician, and engineer. It's a generalization, right? So, can it be overlap? No. Can it be partial participation?
Can be.
No, it can't. Why? Because you have subclasses. Then you can group, generalize the employee, which means all employees should be one of subclasses. So it cannot be partial participation. So in case of the generalization, if you generalize the entity, it should be full participation. So actually, this one does not make sense. Can you understand what I'm saying? Because it is generalized, but it's not full participation. If that is generalized, actually it should be full participation. You understand what I'm saying? But it's not very important in the database. Okay?
What does it mean? It's full participation.
Full participation means all employees should be one of this.
Okay, but you are talking about specialization. But,
No, in case of the generalization.
Yes.
Generalization means first you found the secretary, you found the technician, you found the engineer, right? Using these three groups, you can find employee. Is there any other exception? No, it's not possible. Because this employee created by secretary, technician, and engineer, which means it's a full participation. But that's not very important in the data. So you can simply ignore the generalization or specialization in this. It's a thinking process, how you build such a database. But in real project, so whether or not you realize, it can be either generalization or specialization. So sometimes your customer just give a bunch of data. By analyzing your information or data, you can generalize. Sometimes you need to classify, specialize. So that's very important for your real project.
What about the manager?
Manager is the same thing, but actually this one actually has the non-manager over here. So using manager information, non-manager information, you can specialize into employee, but we don't need the non-manager information. So just ignore that, we leave only the single line. That is the reason. So just simply ignore. That's simple. Sorry. Another example is the car and truck. So let me use this. So forget about the B part. Let's take a look at car. So after your modeling, you found the two entities. One is a car. Another one is a truck. So car has attribute of what? Price, license plate number, vehicle ID, max speed, and number of passengers. While truck has vehicle ID, license plate number, price, number of axle, and tonnage. Can you find any characteristic of these two entities? Both of them are almost similar, same, right? The car is a vehicle. Truck is another vehicle, right? So that is the reason we have the common information, like the price. We have a price here and here. And license plate, vehicle ID. These are the common information. So what can we do? We can generalize into vehicle. So we have the vehicle information over here. See? Vehicle information. Then we can put the 3 common attributes. Vehicle ID, price, and license plate number. Then we can create 2 subclasses, the car and truck. So car has max speed and number of passengers. Truck has the number of axles and tonnage. So that is the reason. Is it disjoint or overlap? Which means, is there any car, both truck and?
No.
Actually, there is. It's a very specialized car. If you open the trunk, it will be truck. Otherwise, it's a passenger car. But we don't consider such a special case. So simply, it's a disjoint car or truck. Also, is it full participant or partial participation?
Full.
It should be full. Why?
Because the vehicle, either she can be a truck or a car.
Because we model. How do you find the vehicle? It's a generalizing from car and truck. Somebody may ask, we have a bus for vehicle. But bus is not considered here. So your data modeling is the same. It should be based on your requirement. In your project, who decides your requirement? You. You are the customer. So that is the reason the first page is very important. So if you put all the requirements, very complicated requirement, probably you cannot complete your project. When me and Ch8 grade your project, the basic line is, bottom line is your requirement. I'm going to take a look at your requirement first. What you plan in this. Then whether your house is built based on your blueprint. You understand what I'm saying? So that is the reason. So your first step is very important. Also, that is not permanent. You should keep changing. Okay? While you are doing the page 2, page 3, even page 4, sometimes you need to go back and change your requirement or request. That's the common thing even in real project. You need to keep communicating with your customer. Sometimes the current technology cannot take care of all the requests from your customer. Okay? Any question? No? I think we have one more example. Let's see. Okay. So arrow pointing is not very important. So very slow. Okay. So there are 2 types of constraint. One is the full or partial. Another one is the overlap or disjoint. Okay. One more thing here. So when you displaying your super and subclasses, the subclasses over here are kind of types. In this case, it's a job type. So it's kind of criteria. So your criteria can be represented just below the master entity or super entity. Then the reader can easily